Here's an example showing initialization of classes. Two classes here, super and 2, and 2 extends super, and the static initializer in each case, inside each of these, prints out the class name. So here's a test that's going to test these. And the first thing it does is this variable t here of type 2 is set to null. Now, if you look at the rules, that is not doing anything which will trigger initialization. So when you come to this line, it will print out no effect yet, which is what you get. And here we then come to the next one, which says t equals new 2. And this being a constructor, before that runs, static initialization is going to take place of 2. And before 2 can initialize, its superclass here, that one's going to have to, initialization of that's going to have to run. So that gets printed out first. So super gets printed out, and it turns from that and initializes this class, and 2 gets printed out. That's why you get super and then 2. Here's an example to illustrate a few more points. We've got this class super here, and a static initializer here just prints out super, and it's got this static int in it, which is set to 1729. And if you don't know the significance of that, look up taxi and 1729 on Google or something. Here's a subclass which extends super, and because it just prints out sub, and well, here we are. Going to have a look at something down here. Right, so this what we've got here, this prints out sub.taxi. Right, well, sub of course inherits taxi, and the question is what gets initialized, and it's the field that it's the class that taxi is in, which is of course super and not sub. So this will cause super to initialize, not sub. And then we come down here and do sub, construct that, and this causes sub to initialize, and of course that would normally automatically trigger super to initialize first, but it won't because it's already been done. So it's just sub that gets initialized. So the net result of all that is you call this here, and before that gets a chance to run, the initializer is done for super, so that prints out super. And then, of course, sub.taxi is printed out, which is 1729. And then this call down here will trigger the initialization of sub, which will print out just sub. And of course, that will not trigger that one first because it's already been done. Okay, let's see the same sort of thing with interfaces. It's interface I with I equals 1, and then I equals something else. And then interface J with J equals something that extends I, and interface K extends J, so K equals some other. And all this lot, call this test.out. Test.out is a static method in this, which takes a string and an int, and that int is returned immediately down there, and it prints out that string equals and that value there. So this is going to print out I equals 2, and it will return 2. So there, J equals 3, and it will return 3, and so on. So let's have a look at what happens. Here we got system out print line J equals I. Right. Now J equals I is declared up here because it's inherited and it's located there. And the important thing to note is that it does not trigger initialization. And that's because this I here is a compile time constant. And what in fact really happens, in all likelihood, is that entire reference is just scrubbed out and replaced with 1. So it's print line 1 basically. because that is, don't forget that's static final because it's in an interface. Now here we got we're printing k.j. Right, k.j lies in j. So it's going to trigger the initialization of j. So what happens there? Well, the initialization of j is going to cause this to run, so it will print out j equals 3, and set that to 3, and then it will print out jj equals 4, and set that to 4, and then that will be the initialization done. And then it's going to try and access k.j, and that's going to be 3, so it will print out 3. You'll notice, of course, that we do not trigger the initialization of the super interface. That's because interfaces don't follow that rule for classes. If it was a class, of course, you would cause the super class to initialize, but not if it's an interface. And if you remember that, I said interfaces are different in that respect. They don't trigger initialization of the super interface.